Okay, well, today in class the video didn't work, so I'm going to hopefully regenerate it. Okay, so some questions that I had in class today is what happens if you have, for instance, something that looks like 1 over 6 minus x. How does the x-intercept work? And the x-intercept is the numerator equal to 0, so 1 equals 0. And there is no variable, so 1 can't equal 0, so there is no x-intercept. So this is my work, and this is what the answer is. So that's how that would work. The other question we had was we had 29, problem number 29, and then we also had problem 37. So we're going to do problem 29 first, and then I'm going to do problem 37. So problem 29, and the main question on this was the intervals, so I'm kind of going to speed through everything. So I have f of x equals x minus 4 over x squared minus 16. So first step is always to simplify. So x minus 4 and x plus 4 in the numerator. So then my domain would be x such that x is not equal to positive negative 4. And then I would reduce. So I have a 1 in the numerator. So x-intercept would be the numerator set equal to 0, and that's a none because they can't equal 0. There's no x with it. Y-intercept would be plugging in zeros, and you can do that at the beginning or the reduced because of the fact that we're dealing with a y. Anytime we're dealing with your horizontal or your y, you can use the original. I like going to the original because I sometimes think it's easier. So 0 minus 4 over 0 minus 16 will give me 1/4, and so it's 0 1/4. Now I'm going to show you the reduced as well. If I put it into the reduced, I'd have 1 over 0 plus 4, which would also be 1/4. The reason why I think it's easier to go back to the original, if I had multi quantities in the numerator or denominator, then I'd have to multiply them together, and I just don't want to have to mess with that. Okay, and then I've got the vertical asymptote. Vertical asymptote is reduced denominator equal to 0. So my vertical asymptote is at negative 4. My horizontal asymptote, again, this has to do with the y, so I can go back to the original. My degree in the original is 1. My degree in the original denominator is 2, so 1 is less than 2, so y equals 0. Now if I use the reduced, I would have 0 was less than 1, so it's still y equals 0. And again, if you had multiple quantities, you would have to multiply them out to get those. So that's why I go back to the original. So I'm down to the horizontal asymptote, so I want to graph what I have so it's easier to see my intervals. I have no x-intercept. I have y-intercept at 1/4. I have a vertical asymptote at negative 4. And do put your imaginary dotted lines there, guys. And then my horizontal is at y equals 0, so I just kind of do my slants. And so my intervals, and intervals again are x-intercepts and vertical asymptotes. And if you look at your graph, it's easy to see. I'm just coming along my x-axis. The first thing I hit is negative 4. So always start at negative infinity to negative 4, and then negative 4, and then I have no other interruptions in my x-axis because that y-intercept doesn't matter. So to positive infinity. This is my problem with my new camera, is getting it far enough away so you can see my whole sheet. Maybe I got it now. Okay. So between negative infinity and negative 4, I'm going to pick negative 5. Any number that falls in that interval. So I'm plugging it into the reduced. So the numerator is positive. Nothing's going to change the numerator because there's no variable. When I plug negative 5 in for this x, I have negative 5 plus 4, which is a negative. Again, I don't care the answer. I just need to know that a positive divided by a negative is a negative. there's my negative, I'll put it right next to it, is a negative. So that means in this section, my graph is down here, and it would look like this. Okay, and then between -4 and positive infinity, I'm going to use +5, just because. Again, the numerator is going to be positive regardless because there's no variable. And the denominator is going to be 5 plus 4, which also would be a positive. So the whole thing is positive, and we're up here, which we should have known because we have to go through the y-intercept and we can't cross the asymptote. So it's going to come from -infinity and down. Never touch, never cross, but come towards it. So that is problem 29.